Hello everyone, I want to talk to you about applying the definition of the derivative. The video should explain where the definition of the derivative is coming from, so please make sure that you look at that before you view this even. What I'm doing today you can find on page 5 of the notes that I uploaded for today. On your upcoming quiz, it will say something like state the definition of the derivative. And in the space that's provided, you're going to give that to me. Okay, so this is going to be a mathematical expression and not one that is given in words. So if we're trying to find the derivative, notice what the video said is that you're using the slope of the secant lines. And we learned this early on, it's changing y, we're changing x, so f of x plus h minus f of x, and you're changing x is x plus h minus x. Okay, so we're using a bunch of slopes of our secant lines to tell us what the slope of the tangent line. Now the fancy way of expressing the slope of the tangent line is f prime of x. Okay, now if you remember from the videos, it says if you pick a particular point and you're trying to find the slope there, so say we want to find the slope right at this particular point, then what we can do is we can do change in y over change in x for those 2 points, and then move in even closer and do change in y over change in x for those 2 points, and then move in even closer and do change in y over change in x for those 2 points. And we'll get closer and closer to our point so that we're almost right up on the point, right? So notice this, f prime of x, which is the slope of the tangent line. Yes, you're using the slope of the secants, but you're strategic about it. You're getting closer and closer to your targeted point, so you're actually taking the limit as h goes to 0. Alright, so this is the entire expression that represents the slope of your tangent line. Okay, so let me go over the various pieces again. You get the slope of your tangent line by using the slope of the secant lines, and you're strategic about it. You're letting the horizontal distance between your 2 points that you're using for your estimation to go to 0, right? So you're trying to squeeze up on your point so that there's no horizontal distance between one point and the other. All right, so there's a very good chance that I'll say, I want you to apply the definition of the derivative to a particular function. On page 5 of your notes, I've given you this function that I want you to apply it to. You guys are accustomed to doing this part right here, the slope of the secant line to a function. So all we're doing that's different is we're adding a limit as h goes to 0, which means that we're basically merging onto this one target point where we'd like to find the slope of the tangent line. So give me 1 minute because I'd like to kind of sketch that in so that you can see where our goal is. Our goal is to find the slope of this line right here at a particular point, right? So say this point is x equals negative 0.25, 1/4. Okay, so let's see what happens. All right, so if we were doing the definition of the derivative, again, the question will say state the definition of the derivative, and then you're going to have at it. Okay, so there's a very good chance I will say, given that f of x equals negative 3x squared minus x plus 7, find f prime of x. Right? So we're trying to find the derivative of our function. Okay, our given function. So here we go. I'm going to restate the definition of the derivative so there'll be some coherency as I go down. Limit as h goes to 0. F of x plus h minus f of x divided by x plus h minus x. All right, so let me get to it. So then f prime of x equals the limit as h goes to 0. I need to put the 0 there, forgot. Okay, f of x plus h says go to your f of x, and all you're going to do is you're going to plug x plus h in for every single x position. So x plus h will go here where there was an x, and here where there's an x. So this equals -3 times x plus h squared minus x plus h plus 7 minus, notice this says plug f of x in, and that's what was given to you. Right, so it should be very similar to what you did when you did the slope of the secant line or your difference quotient. So minus -3x squared minus x plus 7. Running out of space, sorry for that. Divided by, and in the denominator all you have is variables. X plus h minus x. Okay? So at this point, if you remember, the only thing that I simplify is just this piece right here, x plus h the quantity squared. So then f prime of x equals the limit as h goes to 0. I have -3, square the first, square the last, multiply and double, plus 2xh plus h squared minus, and close this off, x plus h plus 7 minus -3x squared minus x plus 7. All right, divided by x plus h minus x. All right, so I realize that I'm trying to cram a lot into these various lines, but I'm not worried about it so much because you guys should be looking at this exact problem right now in your notes where everything is not crammed in. Okay, so then f prime of x equals the limit as h goes to 0. And now I want to distribute the coefficients. So let's see, -3x squared minus 6xh minus 3h squared minus x minus h plus 7 plus 3x squared plus x minus 7 all over x plus h minus x. Okay, we're getting there. Okay, let's keep going. So then f prime of x, notice I'm really careful with my labels. The limit as h goes to 0. Let's see, minus 3x squared plus 3x squared. What else cancels? Minus x plus x. And then plus 7 and a minus 7. And then denominator plus x minus x. Now the reason that I don't try to do too many steps at once is because of, please excuse my dear aunt, Sheila, Sally, whatever name you want to use that starts with an S. It says that addition and subtraction are at a different level than multiplication and division. So don't rush this process. Don't try to do division or multiplication on the exact same step that you're using addition and subtraction. Okay, so here I added and subtracted, so I have -6xh minus 3h squared minus h, all divided by h. Okay, I'm getting there. So then f prime of x equals the limit, h goes to 0. You can factor an h out if that's how you typically do it. Minus 6x minus 3h minus 1 all over h. When you do it in this way, you can see that the h's in the numerator cancel with the h in the denominator. So then f prime of x equals the limit as h goes to 0 of -6x minus 3h minus 1. All right, so you'll notice that this is the first time that I've worried about the brackets, and there's a reason for that. we want this limit to apply to all of that. And before we had quotients, so we could assume that the limit did apply to everything that happens after that. So look, the limit is applied to something divided by something else. Same thing here, something divided by something else. So that's one chunk of information. So you get that same thing all the way down to here. Now, if I drop these parentheses off at this particular step, you could see that it looks like that limit would only apply to the negative 6x, and that would be a problem because I want the limit to apply to all of this that represents the previous steps. Okay, so in order to indicate that, I put a big set of brackets around it. So look, the limit doesn't do anything to this negative 6x, but the limit does do something to this one because this h has to go off to 0. So I'm going to put an arrow that this h is going to 0. Okay, so if we think about that, if we take negative 3 times something that's going to 0, means that this entire thing, negative 3h, is also going off to 0. And then the limit is h goes to 0. Well, there's no h here, so it doesn't do anything to that. So our final step would be f prime of x equals negative 6x minus 1. And we're done. All right, we've dealt with the fact that the h was going to 0. All right, so I want to get to another point, and you're probably wondering, why did I keep writing down the limit as h goes to 0? So from the very beginning, look, many of you guys probably aren't writing this x plus h minus x in the denominator. You're probably saying, oh yeah, that simplifies to h. That makes sense. So this is h. We don't want something going to 0 in the denominator, right? Because you can't have 0 in the denominator. And something going towards 0 is going to be equally problematic. So here too, this denominator is h. Notice here, the denominator of h. Here you can see it, denominator of h, still a problem, denominator of h. Notice this is the only spot where I don't have a denominator of h, and that's where I decided to apply the limit as h goes to 0, and that will get me down to this point. Okay, another thing to note, when I apply the limit, it drops off. Okay, so I don't have that limit as h goes to 0 anymore. And that gets me to what my derivative is. So then the big question is, well, what is your derivative? What does it represent? What does it mean? All right, so I'm going to go back to the picture that I showed you guys earlier. I'm not sure I can get it all in the same frame. We're going to go for it. So let's think about this for just 1 minute. Okay, we start off with a function, and I sketched it for you. F of x is negative 3x squared minus x plus 7. And we end up with the derivative of that function is negative 6x minus 1. Now, I call the derivative, and I'll write this for you so that you can see what I mean. Anytime I say I have a derivative, derivative, I call this a slope generating machine. So you're probably wondering, well, what do you mean by that? Well, if I have a function that I start off with, and somehow I get to my definition of my derivative by doing this long process, this should give me the slopes of any line on this curve. So let's just try it. Notice I started off, and I'm just going to write down what the derivative was. What was our punchline? So when we did all of this work, at the very end, it said that we got a derivative of negative 6x minus 1. So f prime of x equals negative 6x minus 1. So if I want to find out what happens right here at x equals negative 4, then I'm just going to plug it into my derivative. So this equals negative 6 times negative 1/4 minus 1. Which equals, let's see, f prime of negative 1/4, then equals 3 over 2 minus 1, which equals 1/2. Okay, assuming that I did everything right. You can always check my math. All right, So that means that if I go up here and I say, here's the point where I have my tangent line, and I'm trying to figure out how this number factors into all of this discussion that we're having. Okay, so what I'm going to do is I'm going to make a point that we're trying to find y equals mx plus b. Right? We like to find the equation of that line, and we know that linear function has this general form, y equals mx plus b. So if I was telling my reader about the equation of this tangent line right here at x equals negative 1/4, I could say this is y equals 1/2 x plus b. Because my slope generating machine told me that x equals negative 1/4, I should have a slope of 1/2, right? That's how those two things are related to each other. Your derivative is a slope generating machine. It spits out slopes absolutely, positively everywhere, right? So it's going to tell you the slope of your tangent line at a specific point.